Hi there. In this video, we're going to look at how we can draw the lateral surface development of the truncated cone. When we're drawing developments of truncated solid objects, the principle behind everything is basically the same. There'll be just small differences here and there. In our previous video, we talked about how we can draw the lateral surface development of a truncated cylinder. The first thing we did was draw our plan and then our front. Even for the cone, it's the same procedure that we're going to follow. On screen, you can see the question that we'll be attempting. We've got a cone with a base that has a radius 25 millimeters. The total height of the cone without being cut is 70 millimeters. And then kind of the total height of our truncated cone is 50. Or to be a bit more specific, we can say the biggest altitude that we have in our truncated cone is 50 millimeters. First thing is drawing our center line, or the line where our center is going to lie. So I want my center to be at the very bottom of this drawing, because cones sometimes are going to take up a lot of space. So I'm going to measure my diameter, or we can start with our radius still. So I'll measure my radius of 25, and I'll just lift a little bit. There is where my center is going to be. So I can stand here and draw my circle. I'll outline it in advance. So that's my center line. And then just a little bit above this plan, I'm going to draw the base in construction for my cone. So I can just draw a straight line like that. Then to know the bigness of my cone in the front, I'll just raise this point on my plan. This time I'm not raising them all up, going all that way. For a cone, you just need to raise them such that they give you this point here. On the other side, you do the same to give you this point. So this is basically my diameter, but I won't mark it with a compass, since this has the required diameter of my base for the cone. I can just project this point vertically upwards, and I have my base. Next, I need to measure the altitude of my cone. This cone is a right cone. What that means is the base is directly under the topmost part of our cone. So we can also think of it as this angle between the center line and the base is 90 degrees. So I'll just measure a 70 millimeters, stand at this point and mark. That's my top part. And now, since that is the top part of my cone, the next thing that you need to realize is that the point from this part is going to join up, going there. Remember, these are construction lines. They'll go up like that. So this here is the front of my cone, but we've been given a 50 millimeters. Now if you look carefully, that 50 millimeters is giving us the distance to the top of the truncation. So if I get a 50 and mark it, so 50 millimeters measured, stand here, I mark a 50 like that. What I will need to do is use my T-square to draw a horizontal line like this, and then from this point here going this side, there's an angle of 45 degrees. Sometimes the distance you'll be given might be the lowest part of the truncation. What that means, let me show you after drawing. So sometimes in drawings you'll be given the distance from the base to this point on the center line, or the distance from the base to this point on one of the other parts of the cone. So you have to be careful. Not always is the distance to the top there from the base is going to be this point here. Sometimes it might be this point, sometimes it might be this point. So this is our front, then this is our plan. Now whenever we draw developments for our cone, we need to finish up this plan view here with how this truncated part is going to look when we look at our plan. How we're going to do that is first divide our base here into 12 parts like we earlier did. So remember the radius is 25. We'll get that radius, which can also be just gotten from the drawing. Then we're going to mark 2 points like that on each center line that's cutting the circle. So 2, this point here also going to have 2 like that, and then finally the last here and there. Then we're going to have some points here. This time we draw lines passing through the center, coming from one of these arcs that we're just making to the one that's opposite. So that's what I'm going to do right now. The line should always pass through the center. So if you pick a wrong one, for example, I pick this one that is wrong, which is not exactly opposite to that one, you can see the line is not passing through the center. But if I get the correct one, you can see it passes through the center. Then on this other one, you can pick any two, long you get done with the lines. So by virtue of doing this, what we have just done is like joining a line on the base of our cone to the top of our cone, which is here. The next thing is very similar with what we did in the other video. So if you haven't watched it, I would recommend that you also watch it, the development of the cone. Then at this point here, remember, just like we did for the cylinder, we'll raise some lines from these intersections like that, and then now we'll join this marking to the topmost point. That's why that point is very important for the cone. After I've done this, we're going in the right direction. We draw our plan, our front, then we divide our plan into 12 equal parts, and then project some lines going upwards. After you have drawn up to this far, you can draw how this top surface is going to look at on the plan. The easiest way you would do that is get a set square, and then at each of these points you can draw this line, or you can just mark it. So when I am at this point here, remember this slanted line is going to be on this line here. So when I come to this point, I'm going to look for where a line that if I drew would cut this line here. So I can draw a small marking there like this, and then do the same when I go to this point here. This point should be along a line that is cutting my circle there. So I'll come to that point, mark. Here I'll have 2, even at the bottom that. Then go to the next one, mark and mark like that. At the center here, I should have had another marking in this direction, but because the main question is the development, you don't need to worry so much about that. There's a way in which we can draw it. So you proceed to the other one, which is here. And then finally we also have other two here. In this second last one, we have two markings here and there. Then on our last point, which is here, we have a mark like that. You forget about this one here, it was marked accidentally. So the lines we're looking for are going to pass through this point, this one, 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 and this one. Here you can just estimate. So by drawing that, you have an idea of what your cone will look like at the top after the cut. This shape here will usually be an ellipse when you cut your cone in such a way. Now our job is going to be drawing what the lateral surface of this cone here, this part that's here, excluding the top and the base, is going to look like. The first step is you transferring this slanted part of our cone. You transfer it to any point just next to it and draw a straight line like that. Of course, if you want the same distance at the top there, it's not a very difficult process. You just need to draw a horizontal line that goes like that. So the distance from here to there is the same distance from here to there. So here I place my compass, this point, measure the required radius, which is the distance from here to there, the slanted distance. Then I'll draw an arc that goes all the way like that. After I draw this arc, I'm going to get the size of one division for my plan. My plan is here, so I'll get one division of my plan and then mark just like I marked earlier. It's usually a good idea, if you don't want to make a mistake, you mark the 0, 1, 2, and then you also follow suit there. I'll be marking from 0 to 0. So after I get the size of one division, I then come here, so it'll be 1, 2, 3, up to 0. You can see all the points are there. After we have all the points, we need to join these points to this top part here. So from 0, we'll join this point 1, 2, so after you've done this, our job will just be the same as we did for the cylinder. Remember, we got this one, this one, this one, this one. These intersections are the ones that were important for our drawing. So even here, those intersections are going to be very important. However, we won't pick them like we did for the cylinder. If you can remember, for the cylinder we just drew some horizontal lines like that. In this case, we're going to pick the slanted distance. If we want, we can start from this topmost point here, so you get this distance. You can draw an arc like that. You go to the next one, stand at this point, you draw an arc for it. You can see there's something happening. You go to the next one. If you see, this distance here is not the same one as the vertical one. This one would have been the vertical distance would have picked. The slanted distance will be longer. It might not be very visible when it's being done, but if you were to draw the two lines, you would see the difference. If you draw one using the slanted distance, then draw another one not using the slanted distance, you see the difference is very big. Then we'll do one for this point here. Another one. And then finally, the last one. So the procedure is generally the same, but there will be slight changes. Next, we're going to locate our important points, which are supposed to have our curve. We started from 0, so the first point will be here. Then just like we did, we'll go up, then to the right, up, to the right, up, to the right. Make sure you're following your points very well. You might just keep going up. At some point we need to change our direction. The next one will be 0.5. The next one will be 0.6. The next one after 6, you see we have done this part here. Now we're doing this other part. So we'll have a 0.7 here, 0.8 here. So this time we're kind of going down there, and finally our last point is going to be on 0. So we are going up and to the right, up and to the right, up to the right, until we reach this point, which we are saying is 0.6. Then we'll draw a faint line at first, just to see how our curve is going. After we can see how our curve is going, then we can outline. After you're comfortable with the curve, then you can outline this other part. So just like that, you have the development completed. Thanks for waiting until the end of this video. Make sure to drop down all your questions in the comment section so that you can be responded to.